There's a simple three-part fraction there. 4/15 plus 13/15 minus 7/15. Clearly, I'm not going to waste your time. You all know that you add 4 to 13, you subtract 7, and you end up with a reduced version, 2/3. Okay? In the same way, letter B, and I am going to give you that one just to make sure you all remember, letter B is 3x squared minus 8 over x plus 2 minus x squared minus 9. Common denominators are already present, so we don't have to worry about that. We simply have to subtract. So I want you to recognize that this piece causes the x squared to become negative and the 9 to become positive. Minus a positive x squared minus a negative 9. Okay? So now if I actually line it all up like this, and then solve the subtraction, I'll end up with 2x squared, positive 3 and a negative 1, 8 and 9, all of this over x plus 2. Now, I'm not sure if you're going to be really doing any, yes, you will have to factor and reduce where necessary. Let's just assume for sake of argument that this was 2x squared plus 2 over x plus 2. You would have to reduce that top term or simplify it, making it, okay? That would be the way you would have to put the numerator. Okay, so keep that in mind as we work a little further into some more advanced problems. The rules for adding and subtraction. Find the lowest common denominator, add or subtract, simplify, reduce, cancel, all that good stuff. Okay? For number 2, 25 42 plus 11/18 minus 2 over 1. Is there anybody in here that thinks they need me to review that one? How to subtract basic example 2? Example 2? Okay, I'm moving on then. I do want to spend quite a bit more time on example 3. Okay, example 3 has you looking at the real deal now, the more difficult stuff. But this was covered pretty well in Algebra 1. You guys should be just fine. Simplify, which means you are going to have to add everything together, okay, and come up with the combined result of whatever the sum of all this is, okay? So first thing we need to do is get a common denominator. Okay, numerically, I have a 6, I have a 2, and I have an 8. What would the lowest common denominator of those three number values be? Any ideas? 6, 2, and 8? 24. Nothing better than 24. Yep. 24. And this is just how I build mine. You might do yours a different way. Okay. A squared, A, and B squared. What would a common denominator be? What would you do? What would you have to convert it to so that they could all match? Yeah, they all have to become A squared in some capacity. Okay? B or B squared? B squared. Okay? This is the least common multiple that would be found among these guys. It is this least common multiple that you now are converting to. Now, considering this, what you did here is you took this, multiplied it by something, and converted it to that. But what was it that you multiplied 6 by to convert it to that? Looks like 4b squared. Would you agree with me? Multiplied that one by 4b squared. Okay? If you're not sure, take this, the denominator, divide it by the original denominator, and that'll give you the factor that you have to use. So now I have 4b squared. Okay? 4b squared was what I used to multiply. For this one, it's going to be 12ab, right? And I'm just writing it for sake of argument. 12ab, okay? And this one, it's going to be 3a squared. Okay, you multiply by 3a squared to convert. So 9a squared looks like the result, okay? Now that I have common denominators and I've fixed all my numerators by multiplying them by the same thing I multiplied all the denominator by, this one, that one, and the third one, now I can start doing some subtraction. So basically, I look at these and I recognize that none of them are combinable. So I'm going to end up with something like that over that. Okay? Looks like we're going to need to do some factoring. One of the factoring patterns I always forget is perfect squares. So they don't have anything in common, all three of them. But is this a perfect square? Yes. The square root would be 2b. Is this a perfect square? Yes. The square root would be 3a. Is this twice the product of a and b? Absolutely, as long as I use my negative symbol. Okay? 2 times 3 is negative 6. Double it. You get a negative 12ab. So the factored form is that. 2b minus 3a squared. Did it really help us to reduce? No. But you're always going to want to show it that way. This proves to me that you tried to reduce it, but you recognize that there's nothing that can reduce into that. Okay, you guys get what I'm saying? If you have this, the only reason I would want you to not reduce this is if it's prime, irreducible. Okay? Any questions on example 3? Please. All right. Example 4. This is the exact same thing, only you've got a bigger denominator. Your denominator in this case is are some nice trinomials. So, final example. 3 over x plus 3x minus 2. You guys see what I just did? Look at the book and look what I wrote. I just factored it. Okay? I know I'm going to have to anyway. And 2 over x minus 2, x minus 1. Is that right? X minus 2, making sure, x minus 2, yes, okay. X minus 1. Okay, so this and this are factors of the original polynomial x squared plus x minus 6. Okay? And this and this are the original factors, are the only factors of x squared minus 3x plus 2. Okay, what is the greatest common factor in all of this? Well, I've got to have an x squared, x minus 2 I mean. This guy has an x plus 3, so I have to include that. And this guy has the factor x plus x minus 1. So I have to include that. All of that over underneath 3. Okay? Or underneath 2. Okay, but I still have to convert this because, whoops, I didn't write it here. X minus 1. How did I get from here to here? Well, I multiplied by x minus 1, right? Okay? In order to get from these 2 factors to these 3 factors, I had to multiply both pieces by x minus 1. And I'm not going to multiply it out, I'm just going to leave it as a factor. To get from here to here, I had to multiply both pieces by x plus 3. X plus 3. Okay? Now that I've done all that, I can start working the problem, and this is going to be 3x minus 3 And remember, this is saying negative this. So all you got to do is negative 2, and then when you distribute, it distributes the negative for you. So negative 2x minus 6. Y'all with me here? That's the top. Okay, that is the top. All of that would get simplified. And I know I still have to deal with the bottom, but I'm going to go ahead and just make this x minus 9. X minus 9. All of that over these three factors. X minus 2, x plus 3, x minus 1. Can x minus 9 be factored further? No. If it was x squared, it could be. But it's not. It's just x. Any of these factorable? Nope. That's your final answer then. Okay? How are you guys on my left? Okay? How are my guys on my right? Okay. Take your time. Go nice and slow. Should be fine.